Hey guys, Joel Pye here at Advanced Innovations. Welcome back to the shop. As last we met, I've discovered that this particular lug on the mini milling machine base is too short, or this is not far down enough, or whatever. Call it what you will. The course of action that I am going to take, I'm going to mill this off, and I'm going to put a small pocket right there, about the same size as this lug. Then we're going to fit this little beauty in that pocket. And we're going to drill through that pocket and bring a screw in from inside the door. That gives me orientation, that gives me push, gives me all the material that I need to drill through from the bottom and tap it right directly on line where it needs to be. Popped that out this morning in my CNC, giving myself corner rounds so that I don't have to square off the pocket or put chamfers on this or whatever. So let's knock this thing off, make this fit, drill that hole, saw this off the length, and move on to the next obstacle. Let's do it. We're going to get the cutter to 0 on the top plane, raise the table, and then start pecking away at the pocket. I'm going to try to remove as much of this material as I can by pecking away at it like that to avoid cutter flicks. It's still going to twist a little bit in the direction of rotation, but for the most part, this is the fastest way to remove material with a smaller diameter cutter without fear of it breaking. You would never want to go full depth with a diameter cutter this small. This is a 125 cutter, which is about 3 millimeters, a little bit bigger than 3 millimeters. Going to stay a couple of thousandths of away, a couple of thousandths away. I'm going to stay a couple thou away and clean up the scallop marks that are present for an operation like that, because it's going to leave an ugly wall. A few thou away on the DRO, we're going to come back and make a width cut. One side is a climb, the other side is a conventional. I'll cover that some other time. I'm going to check the width of the plug. That's good. Now I'm going to come back for the bottom and scoop off that back wall, and that should do it. That wasn't half as bad as I thought it would be. Okay, pocket's done. The remnant of what was left over has been polished away. The insert fits really well. Nice deep engagement, so it's going to be plenty strong. Pretty much a seamless transition to the original surface. Now I just got to sit here for a while and figure out how to turn that screw to cinch this thing down. I'll probably do that with tweezers, and I'm definitely not going to bore you with that on film. The through hole, the tapped hole that's going to be in there is for the elevator mechanism on the table, and that will be drilled and tapped from behind, inverted. Right. Let me secure it, we'll get back to that. So far so good. The little block is now secure, and it's time to establish the height of the block before the radius is added. I do not have the correct size radius tool, so I'm going to use something that's relatively close and blend it with a file after the fact. It is a lot easier to see where the radius is running out if you use a Sharpie marker and watch the diameter of the tool creep towards the edge of the part, or edge of the feature. Same thing with the vertical sides. What you want to do is watch the bottom of the cutter and not allow that bottom of the cutter to dig in, because that is just one of those moments where you just got to go, don't do it. So mark up the vertical surfaces as well and watch for the cut line to creep down towards the bottom of the cutter. A little bit of oil for the finish pass for a better finish, and you can move on. Next thing I'm going to do is take the whole assembly out of the machine. I'm going to take the block off of the base here deburr it completely, blast it, grain the front and rear faces, and reinstall it so that it looks like the original casting with just the faces machined. Be right back. If you have the room in your shop and a compressor to drive it, a small blast unit is a good thing to have. Small parts, small cabinet. Okay, going the extra mile on this particular part, I decided to relieve 100 thousandths off the top side of it so that I can push a headed brass bushing into this and drill and tap that to accept the 540 left-hand screw that's going to pass through here. The top surface here will act as a bumper, engaging the knee itself, and allow me room for the head of the bushing to be pressed on there and look relatively presentable, I would think. All right, so let's make the bushing, press it on there, tap it, and see if that's true. Also have to make the 540 left-hand lead screw that goes in there. Let's do it. Quick look at the bushing. Bushing goes into the receiver. Everything will be drilled and tapped at assembly. Let's take it over the vise and squeeze it in. I'm going to put a little bit of oil in there first to make sure that this doesn't shave too much of that off on the way through. I do expect to see a little bit of curl on the back, but it's almost unavoidable. This is very soft. Well, since the surfaces that I need to bank from to correctly put a hole in this little boss here are going to be extremely hard to physically pick up, what I'm going to do is I'm going to do the same thing I've done on several other models if you've watched my channel. I'm going to create a surface that I can pick up, and then I'm just going to install the piece and trust my setup and make the feature. That being said, this particular slot right here is as wide as the outer edges of the dovetail, and the outer edges of the dovetail were indicated with the knee in place and the pin in the knee. Say that 3 times fast. Anyway, I trammed the pin in the knee, set my 0 on my digital, removed the knee, and then I used the exact same center line to tram the outside of the dovetail to make sure that the dovetail was a reliable feature to bank from to create this right here. All right, that being said, here we go. This is now a 0 plane when this is located vertically. And this little slot was put in there at the same time this was cut. So now that is my vertical indication tramming point. I can use an edge finder against this face and just offset in and then indicate this for the center line. Problem solved. Once the setup is made, this part will slide into here. Let's get a camera angle that does it justice. There you go. And I'll lock it down with a single clamp, and I will drill blind from the bottom, and I will be 100% assured that the feature, when the drill passes through the bottom and hits that lug, that it's going to go right through where I want it to go through. That's the plan. Let's pop this in the machine, do some rapid indicating, pop a hole in there. That is a very good technique, guys. If you haven't ever tried that, try it. I used it on the steam engine that I did it on the shaper. I'm doing it on the milling machine, and I'm not sure which model this was for. I usually mark the bar, as you can see, shaper base, steam engine, and there you go. Anyway, let's set it up and do it. Hey guys, a little sidebar here before we get into the single pointing of the 540 thread. Now a 540 thread is an 1/8 of an inch in diameter. That's just about 3 millimeters. I think it's a little more than 3 millimeters. But this is what happens when you're turning something or threading something or parting something. Let's see, this is the material, and we're looking straight down the spindle. When that tool comes in contact with that material, several things is going to take place. Several things are possibly going to take place. The material is going to push off center, and if you have a thin piece of material extended far out from the holding points, chuck, collet, whatever, that's exactly what's going to happen. It's going to push away, flex away, deflect. It's also going to want to climb over the top of the tool. And the tool itself is also going to make contact and dive like a parting tool. That's why parting tools snap off. When they snap, they probably snap up here, come apart, and just blow up and scare you forever. God, right on cue. Thank you, Mr. Compressor. All right, now that being said, the one thing or the two things that I want to keep from happening while I'm single pointing this thread is I want to keep the part from pushing away, deflecting, and I want to keep the part from climbing over the tool. There's two ways to do that. Actually, there's two surfaces that need to be constrained. You need to constrain the back surface so that it can't push away, and you need to constrain the top surface so that it can't lift and roll. That is why I made this little guy for my lathe. This is a linen phenolic, 1/2-inch LE phenolic. This is some like Carta. This is the same stuff you'll use for a knife handle. Tough stuff, really tough stuff. Bolts onto the front of the carriage, and this little cutout right here is for a right-hand thread, conventional right-hand thread, because that stops the material from diving under the tool and pushing away, and this is for the left-hand thread. This keeps it from, well, keeps it from lifting and pushing away. I'm going to attach this to the front of the lathe and set it up. It's on a slide here. Not a boom like the camera. Come on now. And since it is micarta, whatever material that is being cut will probably displace some of the material, and the material will not displace some of the part, which is the less desirable scenario. There you go. A micarta follow rest. Quick, simple, stupid. And the first way to establish the hole in the block to support the part was I put an end mill in my collet, and I just traversed this into the end mill and establish the tooling hole, and then I just cut away accordingly. So it was real easy. Let's set up, show you what it's all about. Follow rest is affixed to the front of the carriage, and that is my lock line on my tripod here, popping like that, so forgive me. There's the slide that's on the top, and that is for different size materials. I have a 540, this is my 540 block. 540 left hand on one side, 540 right hand on the other side. And let's say to set this thing up, I'm going to get this block and this camera as close as I can. So right there. Let's lock that in. There we go. I'm going to move the entire setup really close to the face of the collet. And I'm watching my plate in the back here so that it doesn't collide. That'll be my zero stop point. And I will put a stop on the bed so I don't crash into this. Back here by the collet, back here by the chuck is going to be your most likely possibility of having concentricity. So I'm going to move this in until it touches. Just run it in until it touches. Gentle pressure on the back. Cinch up the two screws. Okay, right now that material is constrained from pushing away or coming up. Let's turn the machine on, make a pass. Watch out the end here. It'll probably whip a little, but as this gets closer, it'll stand still. Take a look. Got to tell you guys, it's one of the most useful attachments I've ever made, and if you have any of this material laying around, grab some of it, make one of these. Outstanding thing to have. At least, at the very least, make the contact point out of something that's going to yield to whatever material that you're threading. Let me set up my threading tool, change the camera angle, put a 540 left-hand thread on that for about 1.25 inches, part it off, and check it with the new lug on the base. Hang in. Okay, before I start this, the preferred method of threading in this shop is away from the chuck or the collet. So normally on a right-hand thread, I will have the tool inverted. I will use a left-hand tool because this is a right-hand tool. I'll use a left-hand, insert on this side, flip it over, it's really close. And I will thread away from the chuck or the collet. This particular left-hand thread, I'm still threading away from the collet, but the tool is positioned conventionally and the machine is set so that when I engage my half nut, the tool traverses out. That will result in a left-hand thread. Okay, so for anybody confused as to exactly what the heck is he doing, that's what I'll be doing. Okay, let's do it. 570 RPMs, 40 threads per inch, threading left to right, spindle turning conventionally, machine set to engage reverse. 570 RPM. One easy way to tell if you have deflection or climb on the part, first of all, a climb and deflection combination is going to give you chatter in your thread. If you have simply a deflection, watch at the crest of the thread closest to the collet or the chuck versus out in the unsupported end. You can expect the crest of the thread, the top, the OD of the thread, to have a wider space between, not a wider space between, the depth is going to look shorter and the crest on top is going to look wider. That's because the part is pushing away. This will eliminate that. Let's get back to it. The depth of cut on these passes is very superficial. It's only about 3/1000 of an inch deep. And in between passes, I am checking visually with an eye loop to make sure that the setup is correct and that the land on top of the thread crest is equal all the way down. I've prepared a small brass slug drilled and tapped with the same drill and tap that the part on the base was done with to use as a functional gauge. I'm looking for a very specific feel here. You can also do this with wires or a hard gauge, however you see fit to do it. Functional gauge is always handy to have around. Okay, the mini lead screw has been assembled onto the knee and it lines up very well with the new bushing in the bottom. I'm very pleased with that. Let's see, crank this thing down. That is very smooth. What I'm not quite sure of is why it protrudes out the bottom a quarter of an inch. Everything is absolutely to print, but watch it come out the bottom hole here. And it not only comes out the bottom hole, but it stops way short of where it should. I'm thinking that this shaft here, called out as 2 inches long, could have probably been considerably shorter if I were to move it up now. I would say this much. Take it off of this end. This would shift down. This would be flush. You may compromise the lift. Let's see that. Got a little bit of gear noise on the lift. I don't know if you can hear that or not. I'll figure out why that's happening and make that go away. Let's see when we go flush down here what happens. So figure and you start to assemble this guy. Now let's just put this on just for yucks. You can see that the spindle is well below the table height when it's done. I think I may just adjust the length of this screw on my own at a later date. I'm not going to do it right now because the model is not complete and I don't know what's going to happen down the road. But there you go. The bus repair worked out very well. I'm pleased with the way that ultimately ended up. The brass bushing on there looks great. It looks like any knee mill I've ever operated. You can always see the bronze nut on top of the lug that holds the screw. And this is just a gauge pin with the tap handle stuck to it. Actually, it's not a gauge pin, just a piece of drill rod. There you go. Thanks for watching, guys. That's a wrap. That turned out really well. I am very pleased with that. Leave your comments in the comment line. Hit the thumbs up. Hit the subscribe button. I do appreciate everything. Wherever you are in the world, I hope you're well and happy and safe. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out. Okay, guys, I took a short deviation from the base just for a second to address the little shelf that is going to go on the side where the door is on the base. So this is what you start with. Some flash lines, some undercuts, some gates, and if you put some time into it, this is what you'll end up with. Flash lines are gone. I machined the back flat so it rests square against the casting itself. I also took a light pass on the inside. You can see the witness mark from the cutter right there, just barely on this side, so that the head of the screw has got a parallel surface to bank on, and it's not going to be influenced and bend the screw or cock the shelf either way. So no big deal. Just be careful the size of the screw that you use, that you have enough clearance for the head to turn. This was just about tangent, so I expect this to be a little challenge to put on. I'm going to put it on, show it to you, and we're going to call this base done for this time. There's 2 more holes to go in on the other side, but you've seen one, you've seen them all.